Why does a 100-piece orchestra only sound a little bit louder than one single trumpet? In this video, I'll cover 3 things. The first thing, how sound intensity works. The second thing, how decibel works and sound levels. The third thing is the logarithmic scale that your ears perceive sound on. So, first of all, sound waves carry energy. And this energy that is carried is measured by intensity, which is power per unit area. That's literally the formula. Power per unit area. And it's measured in watts per meter squared. So how intense your sound depends on how much power is in every single meter squared that it covers. If your intensity is higher, that means more energy hits your eardrums per second. But we don't hear this increase linearly. So this moves on to the next part of the video, which is the decibel scale. To measure the level of sound, humans made decibels, and we define sound levels in decibels. Human hearing spans 12 orders of magnitude. So it goes from 10 to the power of negative 12 watts per meter squared, which is intensity, all the way up to 1. 12 orders of magnitude. And we define sound levels in decibels. There's a formula for it, which is this symbol, which means sound level equals 10 log 10 intensity over intensity 0. Let's break this down. And by the way, this formula and every other formula for this topic is on the free cheat sheet in the description. This is the sound level in decibels. And this intensity 0 is 10 to the power of negative 12, the barely audible level on the human hearing scale. It's the threshold of hearing. Let's go through an example. So imagine there's a busy intersection. And there's cars and there's talking and there's horns. And the sound intensity is 3.2 times 10 to the power of negative 5 watts per meter squared. What's the sound level in decibels? Let's look at the formula. It's 10 log 10. Our intensity, so 3.2 times 10 to the power of negative 5, divided by 10 to the power of negative 12. This is roughly 75 decibels. Here's some key facts of decibels. So if you added 10 decibels in volume, then that is 10 times more intensity. But here's the special thing. It only feels 2 times louder to your ears. So 60 decibels, which is about talking level. If you compare to a 70 decibel vacuum, 70 decibel vacuum has 10 times more power, even though the decibels only went up by 10. And 60 decibels compared to 80 decibels, that is 100 times more power, because decibels follows a logarithmic scale. But the perceived volume is only 4 times higher. Here's something important, which I covered in a previous video as well, but I'll go over it quickly. It's the inverse square law for intensity. So as you move away, intensity will drop. And intensity is directly proportional to 1 over the distance squared. This is the inverse square law. It applies to Earth's gravity, it applies to how light travels. And what this means is that if you go 2 times further away from a sound source, let's say a speaker, then the sound intensity is 1 over 4. So it drops by 4 times when you move away, double the distance. A jet is 30 meters away, and at 30 meters distance, it's 140 decibels. How about 300 meters away? How loud is it now? The distance is 10 times bigger. So that means the intensity drops by 1 over radius squared, which is 1 over 10 squared, which is 1 over 100. And by the way, we're looking at a difference here. We're looking for the difference. That's our approach. So let's look at the formula for decibels, which was this. Sound level is 10 log 10. Intensity over intensity. And we're not going to use 10 over negative 12 for this bottom denominator this time, because we're only looking for a difference here. We don't care about absolute sound level. So if it dropped by 100, then the change in sound level is 10 log 10, 1 over 100, because that's the difference in intensity. This is negative 20 decibels of difference. So that means we take away 20 decibels from our original sound level. This gives us 120 decibels. So we moved away 10 times further and we minus 20 decibels. How does amplitude play a role in this? Intensity is proportional to the square of amplitude. So if a sound wave is 10 times louder, it has 3.16 times more amplitude. For example, if a 75 decibel sound makes air molecules oscillate with an amplitude of 10 to the power of negative 8 meters, how about at 100 decibels? Which means that it would have somewhere around 300 times the intensity. Now, the air molecules oscillate with an amplitude of 1.7 times 10 to the power of negative 6 meters. This is less than 1 grain of sand in movement. But if at the perfect frequency, this can nearly shatter glass. Let's go through one last example problem. Let's say there's 4 trumpets playing at once. Okay, these are our trumpets. I know they look like people, but we're trying to imply that the people are playing the trumpets. So we have 4 trumpets playing at once, and one trumpet is 74 decibels. What's the total decibels? Here's a key. You don't add up decibels. You don't just go ahead and multiply this by 4. You add up the intensities of each person playing the trumpet, and then you convert that into decibels. So the sound level is 10 log 10, 4 times intensity, because there's 4 of us, over I0. So 10 log 10 times 4 plus 74 equals 6 plus 74, which is 80 decibels. This makes studying 10 times easier. Go download the free cheat sheet in the description, and I'll include a free surprise worksheet from my premium study kit to help you understand this topic.